All right, hey, it's your old pal Mr. Cook, and we're gonna do these last couple problems, six of them. Shell method. This is fun, easy stuff. I always thought disk method was a little bit tougher. Same thing with the washer method. For this one, like it starts off the same way, graph it out. Then after that, find the intersection points or the corner points. And again, use your calculator. Use solving. Just you know, find the intersection points. Third step, determine if it's going to be dy or dx. And then fourth step, plug it into the formula. So the formula goes something like this. It's 2 pi times like some radius value. And the radius is usually dependent on x or y times the height. And that's usually like, a function of x or y. And then like, your dx or your dy, whatever it is after that. All right. So yeah, let's just go through these and see what we've got. We got six of them. Yeah, six. So let's graph it out and get to work. So we got a parabola, a couple x values, and y equals 0. Rotating it around the y-axis. So let's take a look at what this would be. All right. Oops. I think it was it around the y-axis? Yeah, y-axis. Okay. So it's going to look something like this. We've got our parabola, y equals x squared. It's reflected over, so it's like over here also. And then y equals 0. So that's going to be down here. Y equals 0, x-axis. And then x equals -2 and x equals -1. -2 and -1, huh? Wait. X equals -2 and -1. And y equals... Okay, all right. So it's like over here, actually, then. So here's -1 and -2. So here it is, and then it's going to be It's going to be rotated around the axis, so it'll be like over here also. Okay, so that's like how our shape is going to look. Yeah. Okay. All right. So let's see. So when we put together our integral, we need to determine if it's going to be a dx or dy. In this case, since it's rotating around a vertical line, it's going to be dx. So we go, our limits on our integral, and then we go 2 pi times some radius value, and then times some height, and then dx. The radius is going to be real easy. Whenever it's rotating around the x-axis or the y-axis, it's just like your variable. So we have dx, so it's just going to be x for the radius. And then for the height of the thing, it's just going to be dependent on. Well, okay, so maybe I should talk about what this finds. It's like when you do the cylindrical shell method, you're basically like creating your own little cylinder of rotation, and you're adding up a bunch of these shells to make a shape. Uh, I like to just think of this as a couple different ways, like to put together a volume with these cylindrical shells. You've actually seen it a couple times if you've ever used like toilet paper or paper towels or tape. They all like are kind of wrapped up in the same way. Like you have like these. Like it's always like a cylinder shape, right? But then it's comprised of like a bunch of cylinders added up, you know, and all together, like one of these cylindrical kind of like rolls, right? It's just like a shell, so it's hollow inside. Okay, so hollow, and the inside just like one layer. But then if you add in a bunch of them together, it makes like this three-dimensional shape. That's how the cylindrical shell method works. So the reason that we use this formula here is because it's the area of one of those shells, and then we're adding up a bunch of them. That's what the integral does. As we make our way from our lower bound to our upper bound. So in this case, the lower bound and the upper bound are like -1 and -2. So I guess the lower bound is negative. Yeah, it'd be -2, huh? -2 to -1. Lower bound, lower value. Okay. Anyways, and then the height of the cylinder that you have is going to be dependent on where it is along this like curve right here. So the height is entirely dependent on that function x squared, and that's it. That's as much as you need to do for shell method. These are super easy shell method. quite a bit easier than like the washer counterpart, which is what you'd have to do if you want to do the disc method washer. But this is it. You're all done at this point once you find a radius and then also height. All right, let's move on to the next one. So that's number whatever that was, number 9. Then we've got x squared, y equals 0, and then from 1 to 4, and it's around the line x equals 4. Okay, that's pretty easy too. So let's see, we've got parabola again, and then it's from 1 to 4, and then so it's like it's this shaded region here. And did it say y equals 0 also? Yeah, good. So it's like here, there we go. So it's like this shaded region, and then we are going to rotate this shaded region over the line x equals 4. So like, this line right here. Right, yeah, x equals 4. There we go. So it's going to look something like this. It like rotates back over here. It kind of like, makes like this shape. I don't know, kind of looks like a Hershey Kiss or something like that. All right, so let's find the volume of this thing. So we're going to use the cylindrical shell method. I always like to make something called I call it a test cylinder. And the way that I make these test cylinders is by drawing a cylinder in somewhere, in this region from 1 to 4. So like maybe like right here, and then I'll mirror it over the axis and then just draw it in. So there's my little test cylinder that I like to draw in. There we go. And I want to find everything I can about this cylinder. I want to find the radius of the cylinder, and I also want to find the corresponding height. So this is one of those problems that are offset. It's not on the x-axis. It's not on the y-axis. So this is a little bit more challenging. So let's put this thing together. So it's going to be a 2x times some radius times some height, and then dx. It's dx because it's rotating around a vertical line. Okay, so for shell method, and maybe I'll write out the little table real quick just to kind of break this down for you. With the disk method and the shell method, it just depends on if you're rotating it around a horizontal line or a vertical line. If you're rotating around a horizontal line, the disk method is always going to be dx. And if it's a horizontal line with the shell method, it'll be dy. If you're rotating around a vertical line and it's disk method, then it's going to be dy. And if you're rotating around a vertical line and it's shell method, it's going to be dx. That's why I know that it's dx, because it's rotating around a vertical line right here, right down the middle, vertical line. So see, that's why I'd be like, oh, okay, vertical line, shell method, dx. It's an easy way to tell which variable you're going to be using. Anywho, so yeah, back to the problem. The radius here is what's kind of a little bit weird and interesting, because we're looking for this radius here, this orange radius right here. Okay, so this length. And all we have is basically like the x values to work with. And oh darn it, that should be a 2 pi. I don't know how I got away with writing that x there. There we go. So like at any x value that I have, it goes along the x axis. So like let's say that I stop there, that's x. Then to find this radius, let's call it r. What I got to do is take this total length of 4, from the axis to the middle, so 4, and subtract away x. If I subtract away x, then that gives me the remainder of the radius, which would be 4. So the way that I write in my radius over here, it's going to be 4 minus x. And that gives me the radius, r. I'll write it down in orange. There we go, r. See? And that's a general formula to find it. So watch, even if I made like a different test cylinder, like this one right over here, okay? I'd go along the x-axis to that point, like right there. And if I wanted to find this radius right here, what I would do is I'd take 4, that's the total length from here, from like, this point to this point, and I'd subtract away the x value. If I subtracted away the x value, then I'd only be left with the radius. See, so this formula is going to work every time to find a radius for me. And then the heights are even cooler, because it's just dependent on this little function right over here. And what was that function anyways? I forgot. It was x squared. Okay, so x squared is going to find me the height. So I just write that in over here, x squared. There we go. And then from here, I just got to figure out the lower bound and the upper bound. And that's just, along the x-axis. I start at 1 and I go all the way up to 4. So there you go. There's my volume. I don't need to have that r there, but all the other stuff, that's important to have. There we go. There's the volume for this shape. And that's number 9. or sorry, number 10. So next up, let's take a look at, let's take a look at number 11. I'm looking back, and you know what? I skipped number 7 on the disk method, I think. I did, didn't I? Got that one. Yeah, I totally did. All right, you know what? I'll go back and do that one in a second then. All right, so number 11. Ugh. Number 11. So we've got x to the third and we've got x squared, and it's around the line y equals 1. So let's graph this thing out. X to the third, and then x to the second is going to be like slightly above that, like this. And I know where they're going to meet up. They're going to meet up at 1, 1 and at 0, 0. So, okay, there we go. That's how it looks. And then this is the x to the third. That's the x squared. And where is it rotating around? It's rotating around the line y equals 1. Okay, that's not bad. All right, y equals 1's like here. Y equals 1. That's where it's rotating around. Okay. So let's put this thing together. So it's a horizontal line for the shell method. So that means that we're going to be using dy. So you know what? We better solve both of these equations in terms of y. So the first one, y equals x squared. That's going to turn into x equals plus or minus the square root of y. And I actually only need to use the positive version of this because it's just in the first quadrant only. And then if I have y equals x to the third, if I solve that one for x, then I get x is equal to the cube root of y. And that's not dependent on sign, so I don't have to do a plus or minus in front of there. Okay, and then, the shape that I'm making, let's see here. So it basically looks like this. It's like this outside kind of like dome that's made. And then it's like, just filled in, okay, over there. And then what I'm doing is I'm taking out like a smaller kind of dome from that x squared. So it's like that. So imagine that like I've got one dome and taking out another. So it really does look like a bowl leading into that, because if I take like the shape here, I just subtract it away. It's like it's just a little bit that's left over inside of it. Okay. So, but I'm still just going to be, finding the difference between the heights. It's not actually that big of a deal because basically, like if I draw my test cylinder here, it looks something like this. And I probably should have drawn this graph a little smaller. In fact, why not? I'll just draw it a little smaller, just so it shows up and stuff. Okay. So it's like this. Here's my x to the third power. Here's my x squared. They meet up at 1, 1 and 0, 0. There we go. And then the line y equals 1 goes like through here. So it's like rotated over like this and like this. So like, when we want to do like our test cylinder, if we just go along the y-axis somewhere and like stop like right here maybe. Okay, the height that we need is like this for the cylinder so that it rotates around this. So what we need to do is find like, the radius for the cylinder and then also the height for the cylinder. All right, so here we go. Ready? So this is going to be a dy. It's going to be a 2 pi times the radius, times the radius times the height. All right. What do I want to start with? Let's do the radius. So the radius. Now, when I use these two functions, it gives me like a length. So like, let's say I want to do the cube root. It gives me this length right over here. Okay. So from like the y-axis to that equation. But what I want is actually like this height here instead. So wait, do I want to do the No, I'll do the radius. Yeah. Let's do the radius first. Radius first. That's my bad. Because radius is supposed to come first. There we go, radius. It's like if I go up the y-axis from here, I want like this length, okay? So what I do is I take the length that I have, which is y equals 1, and then I just subtract away this length up the y-axis. So 1 minus y would be my radius length in this case. And then the height is going to be more interesting. It's like the difference between this like red equation here, this red graph, and this green graph. If you find the difference between those two, that gives you the height on this cylinder. So it's just going to be the top equation, top, from the y perspective, most x, biggest x value, I guess you could say. So that's going to be that cube root of y. That's the one that's like on top, so to speak, minus the one that's below it, which would be that square root of x, or sorry, square root of y. And that's it. We just need to, do the y values for this. So let's see, the equation or the coordinates that we had were at 1, 1, and also at 0, 0. So the corresponding y values would be from 0 to 1. So 0 to 1. There's our volume right there. All right, and so I'm sorry I skipped one back a little while ago, number 7. So yeah, I'll just do number 7 real quick. Don't know why I skipped that one. Come on, Mr. Cook, you know better than that. So we've got like a cube function, so y equals x to the third. We've got y equals 8, I believe was the other one. Yeah, and then x equals 0. So that'd be like this line here, x equals 0, the y-axis. So our shaded region is right here. We're going to use disk method, and where are we rotating it? Looks like rotating around the y-axis. So it's going to go back over to here. Darn it. There we go. All right, so let's see. It's rotating around a vertical line. That means that this is going to be in terms of dy for disk method. And let's see. And that's about it. This is actually going to be pretty easy. So, if it's in dy, we got to solve this in terms of y. So it becomes x is equal to the cube root of y. And then we just have pi times, that radius length for one of the cross-section areas. So that's going to be cube root of y squared dy. And then it goes from 0 to 8 on the y-axis. So that one's all done. Man, I wish I would have just put that on the other video. Duh. Let's see. Let me put it on in there. There we go. Is that where it was? No, I think it was there. Yeah. Okay. All right. So number 7 is done. All right. Now moving back over to number, I forget what we had. Was it number 12 now? Yeah, I think it is 12. Okay. So number 12. Number 12. So looks like we got another one of those ones where you got y squared. And if you were paying attention, the easiest way to do this is just to change the variables up. So all you got to do is just switch from x, y axis to y and x, and then just graph it out on your calculator. Just switch the variables around basically. So if I have x plus 3 equals 4y minus y squared, I would just get x by itself. So that'd be 4y. And let me rearrange this. Negative y squared plus 4y minus 3. I'd probably also factor out a negative. So I'd get a negative, that'd be y squared minus 4y plus 3. Oh, and that factors. Okay, this is getting a lot easier. That's going to be y minus 3y minus 1. Yeah, there we go. So that helps me out a lot. So that means that 3 and 1 are where this is going to cross through the axis. So like here and here. Oh, let me use a color for that. So let's use red for this graph. There we go. And that's a downwards facing parabola, so it's going to go like this. I don't know what the rest of the thing is. I forget what the other equation was. Oh, just x equals 0. Okay, that's actually pretty easy. X equals 0 would be like, let's see. Oh, that's just the y-axis. So it's like here. So it's like this shaded region here, I guess. And then it's around the x-axis. Okay, this isn't going to be that bad. There we go. Oh, wait, or is it? Do I have to do like the shell method for this one? Wait, was it around the y-axis or x-axis? Oh gosh, thank goodness it's around the x-axis. If it was around the y-axis, that would suck because it's symmetric. Okay, so there we go. There's our shape. And then around the x-axis, that's a lot easier. It kind of like looks like that. So I don't know. How would you describe this shape? I would like say it's like a, I don't know, the upper half of a donut or something like that. Like when you cut a bagel in half, it kind of looks like that, I guess, because it's like you have these shapes here, and then it's like rotating around like that. So let me draw that a little bit better. It's like yeah, it's kind of like that. Okay, so like this part kind of like goes down like this, and then it has like a smaller circle in between. It's like that. Okay. Yeah, like I'd look at it like the upper half of a bagel. That's kind of how I describe it. So there you go. That's like how that shape looks. Okay, let's find this volume. What do you say? So we got to use the cylindrical shell method. So we draw like a test cylinder in there. That's what I like to call it. So, just pick like along the x-axis somewhere, like maybe right there, and then go the opposite direction, and then do your little test cylinder. That's what I like to call it. Okay, so here's what I got to find with this test cylinder. I need to find its height and its radius. So, interestingly enough, whenever you're rotating around the x-axis or the y-axis, the radius is just going to be whatever the variable is you're using. And since we're rotating around a vertical line with the shell method, this is going to be dx. And so x is going to be my radius. It's that easy. And then let's see. It looks like the height of the cylinder is going to be dependent on like this equation here. Because if you notice, like if I went a little bit further out, right, then the height would be dependent on, like, it'd be that spot right there. Okay, so like the height is just dependent on the function, which is this equation right here. So I can just write that in there. Negative. Oh, wait a minute. This is. Oh, dang it! I do have to get this, don't I? Darn it! What are you doing the right one around the x-axis? Ugh, man, I gotta wake up for a second. I made a total big mistake here because this function is I looked at this one for some reason. I don't even know why. So it's around the x-axis. It is a symmetric problem. Man, I gotta wake up. It's a little late for me to do these problems. Okay. Sorry. Messed up my little graph. Okay. All right, so let me get my bearings on this. Okay, so I've got that equation. I had that correctly graphed. It's like passes through 1 and 3, parabola facing downwards, so like that. And then let's see here. And then yeah, it is about the x-axis. So the x-axis, that means it would be like rotated this way, like that. Okay. And then let's see here. If it's that, then that means that my cylinders are gonna look like this. It's like I've got test cylinders that kind of like rotate this way, like this. So this is gonna be a dy problem. So this is dy. So that's actually not bad. So this is gonna be dy. And then let's see what else. Gosh. Okay. I am so sorry. I messed it up again. I can't believe I keep messing this up. It's because I didn't change the stupid axis. Urgh. So this is the y-axis and the x-axis. I said that at the very beginning too. I'm very sorry about this. So let's see. It starts at 1 and goes to 3. I had it right the first time. I got all like turned around because like I forgot to put the stupid y and the x there. So I was right the first time. This is just like that half bagel shape that we had that I was talking about. That's what this is. Gosh. Okay, so here we go. So it's that half bagel shape, and then when we put together our little cylinders for this, here we go. All right, yeah. I can't believe I totally messed that stupid thing up. So dy is what we're dealing with here. Gosh, all right. And then the Since it's rotating around the x-axis, yes, it is still going to be the variable that we're using, which is y. And then also, it's going to use the height, which is this function here. And that's why I didn't think that it was right. It's because I would have had to solve for x, and it's not difficult to do that because you could just complete the square and solve it. But I was thinking, man, this is like way more complicated than it needs to be. So what was this function based around? Oh yeah, it was this one. So negative y squared plus 4x or 4y minus 3. There we go. Gosh, that was so frustrating. Sorry about that. And then the y values go from 1 to 3, which is what I solved for over here. Man, I can't believe I did that. I had the answer right in front of me. I just didn't know the variable was right. Okay, anyways, so this is your volume right here. And this is actually a pretty straightforward one also, by the way. I just totally screwed that one up because I didn't put the y here when I was graphing it. Man. Okay, anywho. So that would be number 12. Now let's take a look at number 13 and finally 14. So 13, oh, this is a lot easier. So we've got x to the third, y equals 8, and x equals 0. So for this one, let's see how it looks. So it's x to the third. And then what was it? Y equals 8? Yeah, y equals 8. And then y equals 0 probably. Yeah. There we go. So it's this shaded region here. And then it's rotated around the y-axis. So the y-axis is right there. Gosh, Mr. Cook, you dummy. All right, there we go. All right, so there we go. Now, this is going to be a shell problem, so it's going to be 2 pi times the radius times the height times dx, okay, because it's around a vertical line. And then since it's around the y-axis, the radius is just going to be x in this case. Now we got to find the height. So the height for one of my test cylinders, let's draw a test cylinder out here. So that's like one shell through here like this. I can find the radius of this shell by just going along the x-axis. That's what this means. And then the height of that corresponding shell is going to be dependent on two values. It's like the difference between 8 and this function here. It's kind of like, remember the area between the curve stuff that we were doing earlier? Where we took the top function minus the bottom function. It's the same idea. We're just finding that like that one particular length, that height right there. So this is going to be 8 minus x to the third. And then, yeah, so what are the bounds on the graph? It starts at 0, 0. And then it goes up to here, which would be like, I think that coordinate's at 2, 8. Yeah, 2, 8. So from 0 to 2 on the x-axis. There's our volume. For this one, how many more do we have? One more. Okay, so number 14 is next. Man, they did a lot on this video. This is like 7 problems. Goodness gracious. All right, 14. So we've got cosine of x. Cosine like starts at 1, passes through there, and looks like this. What are they limiting us to? So it's 3 pi halves and 5 pi halves. Oh, come on. That's just practice for unit circle. You little weasels. Okay, so let's see. 3 pi halves, that's, oh gosh, for cosine, 0. So let's see here. Oh, let me just draw my little cosine curve. There we go. Okay, so at 0, it's here, and then that's at pi halves. That's at pi. That's at 3 pi halves. So there we go. There's 3 pi halves. Then that's at 2 pi. That's at 5 pi halves. Okay. And, you could find that graph also just by, like, using your calculator, But there we go. There's the graph there. Oh, maybe I'll keep the y-axis. There we go. And then, so we're cutting it off of those two values, and then y equals 0. So like it's this region here. And then we're rotating it around the y-axis. Okay, so it is actually a good idea to keep the y-axis there. Let me like move it closer. There we go. Okay. Wrong color. There we go. So it's gonna be like reflected over. So it'll kind of look like that. Hey, look at that. It's another upper half of a bagel if we rotate it around there. So We would use our cylindrical shell. So we draw a test cylinder. So if I go along the x-axis up to there, there's like the radius for it, and then it'd like match up somewhere over here or something, and then there we go. That's like the crappiest looking cylinder I've ever created. Ugh, it's like a defective cam or something like that. I don't know. All right, so cylinder shell. Here we go. Let's see. So it's around a vertical line, right? Let me double check. Y-axis, yes, is a vertical line, and then it's going to be so that means it's dx. So it's going to be 2 times pi times the radius times the height, and the radius is just dependent on the x value. So we just write x there, and then it's going to go from let's see, 3 pi halves up to 5 pi halves. And then the height is going to be dependent on the cosine function, so cosine of x. This one is actually pretty easy for the last one. There we go. There's your last problem. And let me double check. Gosh, I'm going to just be so mad at myself if I mess up on any of these. So 0 to 2, that's right. This one goes from 1 to 3, that's right. This one goes from 0 to 1, yep. Okay, I did all right on these. I was all just like worried because it's late, and I hope I didn't make any mistakes. I don't think I did, but there you go. So there's your volume for that last one. All right, that's it from for me. That's it for the shell stuff. There's more problems you can review: the 6.2, the 6.3 worksheet. Additional problems in the textbook. Just practice what you need to, and if you need some additional help before the test, just seek it out. Get help before school, after school, that kind of stuff. All right, that's it from me. That's the end of the video. So sayonara, bye bye. Have a good night. See ya.